The paper of the day is Fast and Effective Distribution Key Recommendation for Amazon Redshift. The paper addresses the challenge of optimizing data distribution in Amazon Redshift to minimize network cost associated with pairwise joins in distributed data warehouses. It introduces a novel framework for recommending distribution of keys leveraging a graph theoretical approach called join multigraphs. The authors propose a hybrid algorithm called BAW, which is best of all worlds, which combines heuristics and exact methods to recommend optimal distribution of keys, significantly improving query performance by reducing network costs. In terms of contributions, there are three. First is the problem formulation. The paper introduces distribution key recommendation, that is DKR problem, a novel combinatorial optimization problem, and relates it to known graph problems. The second is theoretical analysis. It proves that DKR problem is NP complete and hard to approximate, establishing the complexity of the problem. Third is algorithm development. The Bouwel algorithm is proposed, which efficiently combines heuristic and exact methods to solve the DKR problem. Here are some of the highlights. Performance improvement. The Bouwel algorithm can reduce network cost up to 32x in real workloads, showcasing its effectiveness in optimizing data distribution. The third is graph theoretical approach. The introduction of the joint multigraph provides a concise representation of the workload history, enabling efficient analysis and optimization. The third is the scalability and applicability. The proposed method is applicable to any column store, distributed data warehouse, and does not require change to the system architecture. Looking at some of the important figures from the paper, the first is Figure 1, which illustrates the performance benefits of the dist key distribution over event distribution, showing up to 18x faster query execution times. As you can see in the figure, you have the schema, then you have the event distribution, and then you have dist key distribution on state attribute, and the fourth sub-diagram, that is the query time. You can see the event distribution versus the dist key distribution, how the query time, that is the BAW, wins. It's 18x faster. So figure 2 demonstrates the joint multigraph and the impact of different distribution key recommendations on network cost saving. The placement makes a difference. Example of joint multigraph and 2 DK recommendations, namely red setting saves 6 units of work, 3 heavy bold edges have their tables co-located. The green setting saves only 3 units of work. Real JMGs can be quite complex. Some of the notable quotes from the paper are, our extensive experimental evaluation on real and synthetic data showcases the efficacy of our method into recommending optimal or close to optimal distribution keys, which improve the cluster performance by reducing network cost up to 32 times in some real workloads. Best of all worlds consistently performs better and rarely ties. Most points queries are above the diagonal, with a few on or below the diagonal. The paper gets 8 out of 10. It represents a significant advancement in optimizing data distribution for distributed data warehouses with strong theoretical foundations and practical applicability. However, the complexity of the problem and the reliance on heuristic methods may limit the precision of the solution in some scenarios. The paper could benefit from more extensive real-world validation and exploration of potential limitations in diverse environments.